This is CP1 Lesson 5, Kites and Trapezoid Properties. By the end of this lesson, you will be able to determine the missing angles on a kite, determine angles and segment lengths formed by the diagonals of a kite, name the parts of a trapezoid, determine missing angles on a trapezoid, and understand the relationship between the diagonals of a trapezoid. So let's review what a kite is before we look at its properties. A kite is a quadrilateral with exactly two distinct pairs of congruent sides. So this pair will be congruent, and I have the other pair, and these are congruent. So they're not opposite sides, but they are consecutive sides. The vertex angle are where the two, I have two vertex angles, it's where the congruent sides meet up. So I have this one here, and I have this one here. And if I come over here, I can go to the other side, and I have this congruent segment with this one and that congruent segment. And those are the vertex angles. These other angles that connect the non-congruent sides are called non-vertex angles. And if I draw a line from my vertex angles, I have reflectional symmetry. If I were to fold this kite over, and let me draw that. So I'm going to draw this little triangle here. And then I'm going to take that triangle, and I'm going to flip it up. And you should notice something about the triangle. It's congruent to the other triangle. And since these polygons are congruent, all their corresponding parts are congruent. So angle B and angle D are the same. So angle B is congruent to angle D. Not only that, these little angles here, and I don't want to name them by three letters, let's name this angle 1, and angle 2, and angle 3, and angle 4. Well, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So this line here actually bisects this angle. So if these are congruent, that's an angle bisector. And these are congruent. Notice that 3 is not congruent to 1, and 4 is not congruent to 2. So what do we know about angle ABC and ADC? They are congruent. So we've got a lot of information here. The kite angle conjecture is non-vertex angles of a kite are congruent. You should be filling in your notes on your iPad as we go through this video. Well, if we draw the diagonals from B to D and A to E, what appears to be true? What does look to be true about AEB and AED? So it's AEB and AED. Those angles look congruent. And if they're congruent and they form a linear pair, then that means they have to both be 90 degrees. And not only that, what appears to be true about BE and ED? Because if I flip this triangle up, they're going to match up exactly. So these are going to be congruent. The kite diagonals conjecture. The diagonals of a kite are perpendicular to each other. Remember the perpendicular symbol? More than that, the one diagonal is the perpendicular bisector of the other. If you draw a good picture, you will know which one's which. Okay, what else do we know to be true? What about BE and DE? I just talked about that. These are congruent. So that one diagonal is the perpendicular bisector of the other. The diagonal connecting the vertex angles is the perpendicular bisector of the other diagonal. What about BAE and DAE? I've already talked about this as well. BAE is this angle here, and DAE is this angle here. I call them 1 and 2. They are congruent. So that the vertex angles are bisected. So the kite angle bisector conjecture is the vertex angles of a kite are bisected by the diagonal. They are divided into two congruent angles. Let me say that again. This angle is bisected, so the two resulting angles are congruent. We're talking about angles here. So there's a lot of information about a kite. So there's the whole summary. The vertex angles of the kite, the non-vertex angles of a kite are congruent. That would be these two blue ones right here. I know that the diagonals are perpendicular to each other. I know that the diagonal that passes through the vertex angles is the perpendicular bisector of the other diagonal. And I know that this diagonal here bisects this big angle here and bisects that angle there. So there's lots of properties of kites. And yes, again, you will see this on the ACT and PSAT. So let's do a problem. I have a kite here, and I know that I have some perpendiculars. So find the missing measures. What's the measure of angle B? Because that's the easiest one. We know that that has to be a right angle, so that's 90 degrees. And how long is A? Because I know that this diagonal, this big one here, is bisecting the other diagonal. So that this segment, and what appears to be true generally is true, this segment here is the one that's bisected from the non-vertex angles. So A is equal to 4 centimeters. And please remember to put in the units. What else do we know? Side C. Well, I know also that we have these consecutive sides congruent. This side's congruent to this one. So C is the same as this 5 centimeters. Let's not make this hard. It's easy. What appears to be true generally is true. Where's D? D is this big angle here. It's in green. I'll keep it in green. It's this one here. Measure of angle D is equal to the measure of that big angle. So 32 degrees plus 60 degrees. So that's 92 degrees. Whoops. And I know that this diagonal here bisects the vertex angles. So if the right side is 30 degrees, the left side is 30 degrees. So again, it's kind of like a puzzle. And that's all there is with kites. If you draw a good picture, what appears to be true generally is true. So you won't have to remember which diagonal it is. Just look at your picture and you'll know which one bisects which one. And they are perpendicular always. Now let's talk about trapezoids. Trapezoids has exactly one pair of parallel sides. And when you look at these sides that are parallel, when you have the non-parallel sides forming an angle with the parallel sides, those are called base angles. So that's a base angle. This is a base angle. This is a base angle. And this is a base angle. So they're all called base angles. Generally speaking, I'm talking about the bottom bases. But it doesn't matter. They're base angles because there are two bases there. So what do we know about consecutive angles in a trapezoid? Well, these are parallel lines. So what's this measure? This is 80 degrees, right? And because we have a linear pair, that's 80 degrees plus that other obtuse angle, they have to add up to 180. So this has to be 100 degrees. So if you take and look at the upper base angle with the lower base angle, what happens to be true about these angles? They turn out to be supplementary. Is that really true? Let's check the other one. If this angle is 135, then this angle is 135. And because these angles form a linear pair, these angles, 135 plus my unknown angle, have to add up to 180. So that's 45. It's 45 plus 135. Is that 180? Yes, it is. What about the base angles? Do these have to be congruent? No. Are the base angles supplementary? Not necessarily. So it's the one upper base angle with the lower base angle. So they're the consecutive angles we're using the upper and the lower. So the consecutive angles between the bases of the trapezoid are supplementary. And in case you forget what supplementary means, the sum of those angles is 180 degrees. So which angles are supplementary here? I'm looking at consecutive angles, and it has to be base angles. So A is consecutive to D. So the measure of angle A plus the measure of angle B has to add up to 180. Can you name the other pair? The other pair would be this one. And I'll use different tick marks because they're not necessarily congruent. The measure of angle B plus the measure of angle C have to add up to 180 degrees. Now we can have isosceles trapezoids. An isosceles trapezoid is a trapezoid where the two legs here, this is called a leg and this is called a leg, they are congruent. They have the same length. Well, if that's the case, I can get a whole lot of nice properties for trapezoids. So this is the isosceles trapezoid conjecture. The base angles are congruent. I have a picture down here, but let me mark it up here. This angle here is congruent to that angle. The upper base angles are also congruent. But remember, this upper base angle, this green one, is supplementary to that purple one. And this one is supplementary to that one. So the upper base angles are congruent as well. And if I were to draw a diagonal in here, and we have some diagonals here, I'm going to get an isosceles triangle out of that. These segments are going to be congruent. The diagonals are congruent. And you can guess that even this little segment here is going to be congruent to that one there. So the diagonals are congruent. So the base angles are congruent. And it's written here, but I'm going to write it again. And the diagonals are congruent. So let's look at this picture. We've got some kites here, actually. This shape here, that's actually a kite. And so we know that the opposite angles here are congruent. So if that's 154, this is 154. And I have a trapezoid right here. This is a trapezoid. And I know that my angles, my upper base angles, and it's an isosceles trapezoid, that makes it even nicer, but my upper base angles are supplementary, so that this angle here has to be 180 degrees minus 78 degrees. Well, that ends up being 102. Then I know that this angle is congruent to this one, so that's 102. And I know my base angles. This 78 degrees is congruent to this base, which is 78. I might have done more than I need to. I'm just filling in all the question marks. Now to find x, I want to find this value, x plus 154 plus 102. That forms a full circle, is 360 degrees. So x plus 256 is equal to 360 degrees. And if I subtract that, 360 minus 256, that's 4. So x turns out to be 104 degrees. Please correct me if I'm wrong. I'm just doing the arithmetic. Same thing with y. This 160-degree angle and this angle, they're the same. That's 160 degrees. So y plus the 160 plus 102 has to add up to 360. And if I just subtract the 160 because that arithmetic is easy, I get y plus 102 is equal to 200. And if I subtract 102 from 200, I'm going to get 98. So that's 98. You might want to go through that problem again on your own. On problem number 10, we have a missing angle. It's right over here. We need that angle to do that. So I'm not going to do that because that is a homework problem. So we learned a lot of things. Let's go back to the very beginning. And we found the missing angles on a kite. We found that the or opposite angles are, no, the non-vertex angles are congruent. I had to think for a second. We have the diagonals are perpendicular. We actually have a perpendicular bisector in the kite. And we also have an angle bisector. The vertex angles are bisected. There's a lot of information. But like I said, if you draw a nice picture and you draw it pretty accurately, you will be able to see that. On the parts of the trapezoid, we have the legs, and we have upper base angles. I know that sounds crazy, doesn't it? And we have the lower base angles. Think of the isosceles trapezoid or the legs of a trapezoid like isosceles triangles, lower base angles. Determine missing angles on a trapezoid. We know that consecutive base angles, upper and lower, because it has to be one from the top and one from the bottom, base angles are supplementary. Understand the relationship between the diagonals of a trapezoid. In particular, if I have an isosceles trapezoid, the diagonals are congruent. And not only that, if I have an isosceles trapezoid, the base angles are congruent. The upper base angles are congruent. And the lower base angles are congruent. There's a lot you're going to have to remember. So you really need to do the homework. You need to reread these notes and make sure that you actually can make the statements about all these properties, because there's still lessons 6, 7, and 8 coming up, so there's a lot of information in this particular unit. So you're going to have to remember about kites and about trapezoids, and everything is summarized right here. Assignment lesson 5 is due on Tuesday, so you should have that tried. Answers are online. Please check your answers. As always, you need to check your answers, because there's no way for you to know if you did it right or wrong unless you check your answers.